Mimi nilikuwa najua mimi nilijua
Just for
We have Zabu Pogon.
huko tu.
Zabu.
Yaje maniga.
Poa. Gotea Pogon.
Gotea.
Mwambie nisalimie.
Aje Samoei.
Poa sana.
Unaonaje hiyo game ya Chelsea we Pogon man?
Ishia game ya Chelsea ni
Sunday ni chinja huwa.
Hiyo game tukuje Zoom wote tu watch.
Mzee mtanibadiza bana.
Nani ana share screen man?
Hatuwezi fanya huko, hakuna network kwa jamaa. Hatuwezi fanya hiyo.
Basi tufike Radio Jambo pale. Wewe nyamaza. Sijui.
So, okay, I have a few questions because I know you already covered this question. You're going to answer, and I'm going to let you.
Oya.
He how can you just go to YouTube and search how to be beautiful?
Okay, I hope you can now hear me. Just a minute. So, today I want us to revise a Form 2 topic. A Form 2 topic. Today we are going back to Form 2. So our revision will be in Form 2. And I would like us to discuss a topic here, a very nice topic that will help us revise properly. Form 2 topic. And this topic will be turning effect of a force. Turning effect of a force. So I want you to write here, turning effect, and turning effect of a force. So that's what I want us to discuss. So I want to share the screen. I hope everybody is okay. Turning, tunaandika hivyo. Andika turning effect of a force. Turning effect. So this is what I want us to discuss today. Turning effect. Sorry. Kidogo. Share. This will be clear. Turning effect of a force. So write that turning effect of a force. Stop share. Andika turning effect of a force. Turning effect of a force. That's our topic of the day. Turning effect of a force. Okay, turning effect of a force is we should start by understanding what the meaning of the moment of a force. That's what we should start with. So we should start with the moment of a force. Moment of a force. So what is moment? In the first place, moment is normally called the turning effect of a force. So it should be called the turning effect of a force. So moment is equal to force. So I want us to write moment is equal to, so we should write this moment is equal to force times distance. Equal to force times distance. So for example, if you're given a force of 20 newtons, force of 20 newtons, at a distance of 2 meters, moments put force times distance, which is equal to 20 times 2 to get 40 Newton meter. So that's why we should start. That's our starting point. Now, next thing from there, after understanding the meaning of moment of a force, we need to understand now where does it come in. So moment is equal to force. The distance must be perpendicular. I know when you were young, you participated in this game, whereby one person is seated on this side, like this. one person is seated here. One person is seated, you had something like this. One person was seated here on one end, and another person on the other end, and he started swinging. Do you remember that? Huh? So he started swinging. That was a practical that you are doing unknowingly, a practical of movement of a force. Today, I want us to discuss that and see how this topic is applied. I want to show you how to answer the questions clearly and you can manage to get all the marks in a KCSE question. How can you achieve 100%? Like if you're given a question of 3 marks, how can you be able to get 3 marks completely? How are you supposed to answer those questions if you're given in a KCSE question? So after knowing moment is equal to force times distance, like the moment of this person, of course, if this person is 50 kg, force, sorry, if the person is 50 kgs, 50 kg, force will be equal to 500 newtons. This person, this distance, this distance may be 2 meters. And then for them to balance, this must also be 2 meters. And the person must also be 50 kg. So that force will be equal to 500 newtons. So moment on this side, moment will be equal to 500 times 2 to get 100. This other side the same, 50 times 500. Sorry, 50, no. Should be 500 times 10. 500 times 2 to get 1,000. This 1,000 on both sides. So for you to get equilibrium, what am I trying to derive? I'm trying to bring in the concept of moment, meaning turning effect of a force. That concept is bringing us to a principle that we are supposed to follow in this topic. So the principle that is normally followed, and we normally call it principle of moment. Principle of moment. Principle of moment says that principle of moment, because that is why we should go direct after the introduction. You're supposed to go to principle of moment direct. So tuandike pale quickly, clear. So andika principle of moment. So principle of moment is stated clearly, and you don't explain it. You're supposed to write it the way it's supposed to be written. You andika the principle of moment. Principle of moment. What is the principle of moment? How does it state? What does it state? Never explain the principle of moment. I repeat that. Never explain. You're supposed to state it the way it's supposed to be stated without explaining anything. So ukienda kuelezea hapo utaanguka. So ensure that you don't explain anything. You clearly state it the way it's supposed to be stated. It states like this. The principle of moment states that. So you are supposed to write, it states that can write as maybe a column like that. It states that for a system in equilibrium, for a system in equilibrium, for a system in equilibrium, the sum of clockwise moment is equal, okay, the sum of clockwise moments about a point must be equal to the sum of the anticlockwise. The sum of must be equal to the sum of anticlockwise. moments about the same point. About the same point, full stop. States that for a system in equilibrium, the sum of clockwise moments about a point must be equal to the sum of anti-clockwise moments about the same point. That's something that you need to write without explaining. Don't explain anything. Write it the way it is, and you get the marks. So don't explain. For example, I'll just go direct to questions and see how you are supposed to. Maybe I explain the way you're supposed to answer the questions. We're going to start by an example here. I hope everyone is here and clear, so that I can dictate a question. Example one. Example one. Example one. I want you to write this. A boy. A boy of mass. A boy of mass 40 kgs. Sits at a point. Sits at a point. A boy of mass 20 kg sits at a point of 2 meters. 2 meters from the pivot. From the pivot of a seesaw. Seesaw. Hope you're also writing. Find. This is a very simple one. You're starting with the simple ones. Find the weight of a girl who can balance the seesaw, who can balance the seesaw, who can balance the seesaw by sitting at a distance. At a distance of, by sitting at a distance of 3.2 meters. By sitting at a distance of 3.2 meters from the pivot. I have 2 minutes to do that. I'm sure everybody can do that comfortably. I'm almost sure. So I want to get the answers direct. We are starting from the simple ones, then we go integrating. Yeah, we are going from the simple, from what you know to what we don't know. So quickly. You're done? Uh-huh. Uh-huh. Who has finished? Uh-huh. I can see Crispus. Crispus, your hand is up. Crispus, your hand is up. Crispus, yeah, I'm waiting for your answer. Hmm? Crispus. So quickly, maybe because of time, or I can change. I think Crispus is not connecting well. Uh-huh. Abdimajid. Abdimajid, you can answer. Uh-huh.
Yes, the answer is 250 Newton.
250?
Yeah.
Just take us through what you've done. Just read whatever you've done. Hivyo hadi mwisho chapter.
So sum of clockwise moments. So the sum of clockwise moments is equal to the sum of anti-clockwise moments. So 400 times 2 is equal to 3.2 times opposed to the weight 2 of the girl. So it is 250 Newton.
Good. That's very nice. So the answer is? Good. So what you write is the first thing in this question. This is what I wanted to make very clear. That was a good thing. That was a good plan. So the first thing you need to know about this question, it's a bit sensitive. It looks very easy, but you need to be very careful on how you're answering it. So the first mark in physics, we normally mark formula, substitution, then answer. So this is what I want you to understand, because some more questions are coming, and this is what I expect you to do. So always, when you get such kind of a question, the first thing to write is the formula. So now usiandike initials, andika clockwise moment is equal to anti-clockwise moment. So clockwise moment, if I draw this thing quickly, so there's a boy of 40, so you can see this is 400. Sorry. So this is 400 newtons. Distance ni ngapi? 2 meters. This other side, we have x, and Iko sawa bana? Safi. Thanks. Hapo. Sawa. There's a big problem, But anyway, I hope you are still there. You have been very patient. We have been addressing a problem with the host, and I hope we'll still do something. So quickly, we'll be a bit fast because our time has really been lost in that in trying to handle that problem. A lot of time has been lost. So nitaenda direct, hakuna kunini sasa. So I'll go direct to main. So quickly, I'll be a bit faster. I hope you are going to understand because I will be very fast. Itakuwa fast sana kwa sababu time has been lost. These are machines that bring problems here and there. So we need to understand. Okay, quickly, before we proceed, I was saying that you need to state, the first thing you need to state, unasema clockwise, moment is equal to anti-clockwise moment. So unasema force 1 times distance 1 is equal to force 2 times distance 2. So that's okay. So that's what I was saying. You need to make sure that you state the formula, then you substitute, then you go to the answer. Because of time, you know how our time has been lost. But let's first of all write this question. Tukifanya hii tuende kwa ingine. Niwaonyeshe zile double coupling nini hizo zote. So I'll be a bit fast. So ukiona nikiharakisha, tafadhali understand because of time. Masaa yetu imekuliwa mahali. So let's do this. Fanyeni swali kwanza. Fanyeni swali. And I want us to get kindly do this question clear. I want us to clear all that. So to me, we have this. So that's our pivot. Stop share. Quickly. So we have, at this point, I have down here, I have 4 centimeters. To that and that. Then I have 5.0 newtons. Then here I have 4.6 newtons. 4.6 newtons. Hapa ni 2 centimeters. Then again, I have another one here at 4 centimeters again. 4 centimeters, I have 1.3 newtons. Then from there, I have another one here. D have 4.2 newtons. You're told to find B. Find D. Find D. Find D. Find D. Find D. So if you're given such kind of a question, unasema clockwise moment equal to anti-clockwise moment. Clockwise moment, we have 2. We have 2 for the clockwise and 2 for the anti-clockwise. So we have a D times, ensure all distances are measured from the pivot. All distances are measured from the pivot. It's not D times, it's supposed to be, we have 4.2, we have 4.2, distance yake itakuwa ngapi? 4.2 times the distance will be 4 plus D. We can use centimeters, no, let's use meters. Okay, because of time, I'll go very fast. So I can divide all through by 100, or even I can also work with centimeters, which is still okay. So 4.2 plus times 4 plus D. So that distance will be 4 plus D plus distance for the 1.8 will be 4. 4 times 1.8 is equal to, anti-clockwise will be 4.6 plus the distance is 4 times 5.0. So the secret here is we need to be very careful on the distances. All the distances must be measured from the pivot. So if I look at the clockwise movement, this is clockwise. When I'm moving like this, that's clockwise, that is anti-clockwise. So in the clockwise movement, in the anti-clockwise movement. So ensure that all the distances are measured from the, being our pivot here, this being our pivot, the distance for the first moment, which is D inclusive there, which is including D. So our distance is 4 plus D. Don't be confused and take the distance as D only, because that is not the pivot. The pivot is here at P. So the distance at this particular case will be 4 plus D. That's why I've written distance is 4 plus D times the force. Force times the distance, 4 plus D. Plus the other moment will be the other force is 1.8 times 4 again. 1.8 times 4 is there, is equal to the anti-clockwise moment is 2 times 4.6 plus 4. I've written 4 because it is very clear from our diagram that 4 is starting from the pivot. So we do our calculations very fast. 4.2 times 4.2. We can use a calculator at that point quickly. Allow me to use my calculator here. So it is 4.2 times what? Times 4. That is so easy. 16.8. 16.8 plus 4.2D plus 1.8 times 4. 1.8 times 4. 7.2 is equal to 4.6 times 2 is 4.6 times 2 is 9.2 plus what is 5? Is it 5 point? Yeah, 4 times 5.0. Good. 4 times that is 20. So 29.2, 16.8 plus, sorry, I can't do that. I can simply add 16.8. 16.8 plus 7.2 itakupatia nini? 16.8 plus, I like terms together. 16.8 plus 7.2 plus 7.2 will give you 24. So 24 plus 4.2D is equal to 29.2. We bring the like terms together. We take this to the other side. So 29.8 minus 24 will be 29.8 minus 24 will be 2 minus 24 will be 5.8. So 4.2D is equal to 9.8, right? So divide by 4.2 by 4.2. So 9 divided by 4. Sorry. Is equal to 9. Okay, 9.8. So it's not 9.8, but we want to undo that. Very good. So I've said it was 9.2, it was 29 point. So we are subtracting 29.2 is 5.8, sorry. 5.8 divided by 4.2 divided by 4.2, which is equal to, Crispus, 5.8 divided by, we are dividing now, 5.8 divided by 4.2. This 4.2 here, 4.2 will be 1.38. 1.38. Anyone with that answer or with a question before we move to the next? Anyone with that answer? Somebody? 5.2. We're subtracting. Let me see. 5. Let me see. We were having 29.2 minus 24. That should be 5.2. Okay. Thank you for that. That's a very good observation. So we are supposed to have 5.2. 5.2 there. So that you can have 1. The answer is equal to 1. Good, very good. The answer is supposed to be 1 because it's 5.2. 5.2 divided by 4.2 to get 1. The answer is 1 centimeter. So, thank you for that. 1 centimeter. I hope everyone has 1 centimeter. That is the answer for that. We are a bit fast, so tunaenda mbio. Our time is far much gone. So I want to give you our parallel forces. Hiyo ndio najua mnahitaji for now. A question on parallel forces. Parallel forces, where like parallel forces, that's where I think we need some help for now. Parallel forces are those forces which behave like this. Unakuta mtu mmoja ameshikilia hapo, mwingine ameshikilia hapo. So unaulizwa, you ask the question there. So the two forces are parallel to each other. Hakuna yenye ati inaenda chini ingine juu. They are both parallel forces. Like this question. I want you to write the question very fast. Tuandike swali. I know tutamanage na hiyo speed. Hiyo speed bado tutamanage. Question is there. A uniform metal rod. A uniform metal rod. A uniform metal rod. I hope dictating will be a bit faster. A uniform metal rod of length 80 centimeters. A uniform metal rod of length 80 centimeters and mass 3.2 kgs. A uniform metal rod of length 80 centimeters and mass 3.2 kgs. And mass 3.2 kgs is supported horizontally by two vertical spring balances. By two vertical spring balances. Are you writing? Yeah. I hope you are writing. By two vertical spring balances, C and D. By two vertical spring balances, C and D. Balance C is 20 centimeters from one end. Balance C is 20 centimeters from one end, while balance D is 30 centimeters from the other end. Balance C is 20 centimeters from one end, while balance D is 30 centimeters from the other end. Find the reading of each balance. 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 So I won't write it very fast. I can just drawing the figure. This is how now the figure looks like. We have a balance here. And that's our rod. So I will format a rod of 80 centimeters, supported like. Our rod is just there, 80 centimeters of mass 3.2 kgs. Ukisikia 3.2 kgs, there's something you're supposed to know, that the mass, it is uniform. Therefore, our mass is exactly at the center, 32 kgs. 32 kgs. So only 32 kgs. Apple. Then that's the center at 40 centimeters. So that one, at that point, we have 40 centimeters. At that point, somebody is misbehaving, somebody somewhere. So this is how it's supposed to be. So 80 centimeters at the center, I've addressed because of somebody there was trying to. So those coupling, so there's somebody here. So that is how it is. Ignore that person when anasema lunch hapo. Hapa kwenda is supposed to go for lunch. So this one here, we are told this is a very important thing. Before you go for your lunch, make sure that you understand completely how to solve this. So we are told that there is supported by horizontally by two vertical spring balances C and D. Balance C is 20 centimeters from one end. So if I take that at here, at this, so this balance here is 20 centimeters from one end. So from here is 20 centimeters. Centimeters, while the other balance is 30 centimeters from the other end. This is 30 centimeters from the other end. So 30 centimeters. Very good. Now, you are told to read to know the nini. You're supposed to find the reading of each balance. So what you're supposed to do here, you can call this force 1. Force 1. force 1. Call this other one force 2. Force 2. Ama, you can call this A. Let me just can call this A. A, and you can call this B. That will be easier. You can call that other one B. So the first thing to say, you start by stating that A plus B should give you this 3.2 kg. This was 3.2 kgs. 3.2 kgs. It was 3.2 kgs. This was not 32, it is 3.2 kgs. 3.2 kgs. There's a point there, I hope it will come clear. So that is 3.2 kg. So the first thing to say, you start by stating that force 1, ama A plus B, A plus B should be equal to 3.2, 32 newtons. A plus B should give you 32 newtons. A plus B should give you that 2 newtons. Because this is 32 newtons, times 10. So this is 32 newtons. Therefore, so the secret is only one here. Take one of the A or B to be your pivot. Because you don't have a pivot at this particular point, we don't have a specific pivot. So we select one of them to be our pivot. So our pivot should be, here. Let's select A to be our pivot. So if we take A to be our pivot, at A, utaandika hapa clockwise moment. Clockwise moment is equal to anti-clockwise moment. Nataka niandike na change. Yeah. Good, so that I can write faster. So utakuja at A, taking moment. Moment at A. Kasema clockwise moment. Moment is equal to anti-clockwise moment. Clockwise moment at A, clockwise moment will be, this will give you the clockwise moment, and B will be providing the anti-clockwise moment. So clockwise moment here will be 32. What is the distance here? This is 20 centimeters. And this other one is 10, because this is 30. Eh? So taking A to be a pivot, clockwise moment will be 32 times 20 is equal to the anti-clockwise moment. So there will be that. The distance is from 20. Here we have 20 and a 10 is equal to 30. You can either use 20 or let me just use meters. So that's, let me just use meters. So 20, itakuwa 20, 0.2 times 32 is equal to 0.3 times B. So 0.2 times 3 times 32 will be 1.6. No. 0.2 times 32 will be 6.4. 6.4 is equal to 0.3 B over 0.3 over 0.3. No. 0.2. Yeah, over 0.3. 6.4 divided by 0.3 is 21.33. So B we know that our A is equal to Jui, we don't know, but B is 21.33. And from here we get said that A plus B is equal to 32 Newton. So ukitaka A itakuwa 32 minus 21.33. So sorry, and so itakuwa 32 minus 21.33 minus 21.33. So 32 minus 21.33 is what? 32 minus 21 minus 21.333 will be 10.667. This will be equal to 10.667. Therefore, force at A is 10.667, and force at B is the reading will be 21.33. 21.33, sorry. 21.33. Is it clear? Any question? Any question? Let's check whether there is anybody with a question. Any question? This is an area I wanted us to understand, although we had some challenges. We have experienced a small challenge there of network, but I hope the concept is at home. So this is coupling. No, these are parallel forces. Actually, it's called parallel forces. So if you're given this kind of a question, the first statement should be the two forces should give you the final. Remember, anytime you are told that you're given a uniform meter rule, the mass of the ruler or the force, the weight, falls at the geometrical center. If this thing was 80 centimeters, so geometrical center is at 40, that is where the weight falls. Automatically, the weight goes to the center, to the geometrical center of the ruler. So before you even start, the first thing to understand is that if the nini is uniform, if the meter rule is uniform, or whichever bar you're given is uniform, automatically the force goes to the geometrical center. The force goes to the geometrical center. That's how. So anyone with a question in that? Anyone with a question? So if you have no question, you can turn. You can decide to use, I don't know, you can decide to use you can decide to use B as the pivot. If you use B as the pivot, what will happen? If you happen to use B as your pivot, you expect things to change because hey, I know you are fine before at 12:30, but you have really stayed. But very good, you have been very patient. Our lesson was supposed to end at 12:30 to end all the way, but it's good. It's because of the challenge. I know next time you'll keep time. So you can try some questions. You can get a book like KMF or any other revision book with 5 questions on turning effect of a force. So, despite the challenge, at least you have done something. So you have yourself a good weekend. Although you have been very patient. Since 12:30, that was the time our lesson was supposed to end. Anyway, you can have a good weekend. Thank you.